This is our last section for Chapter 7, Law of Cosines. We saw that we could use law of sines to help us solve triangles that were not right, so those non-right triangles. However, we saw that the law of sine only worked in certain cases. When that fails you, then your next line of defense is the law of cosine. So we're going to talk about that today, see how it works. I will warn you, the equation for law of cosine is a little intimidating at first. Certainly not as easy as that proportion for law of sine, but it is something that works, and it's something that's not terribly difficult as long as you know what to do and sort of some tricks that I'll show you to make sure that you get things correct. So let's take a look. Here is the law of cosine. All right. Again, we'll let A, B, and C represent just any non-discriminant triangle. Obviously, this would work with right triangles as well as non-right, but our purposes will be for those non-right values, or non-right triangles, rather. So A, B, and C represent angle values, the capital versions, whereas the lowercase a, b, and c represent side lengths. And here is the equation. Now, notice they give you three versions of it. The reason they do that is you could view the world from three different perspectives. You could view the world from A and A, so angle A and side A. You could view the world from B and B and so on. Again, so you don't need to know all three of these because notice they're all three basically the same. Personally, and this is just a personal preference, I've memorized the top one and simply apply it to whatever situation that I happen to be in. Again, if you want to memorize all three, you are welcome so to do, but you really need to only memorize the one. Notice that the first portion there of the equation looks a lot like the Pythagorean theorem, and we will use a right triangle to solve or to prove this situation, actually two of them. And then the back side, obviously, you've got your cosine in here for law of cosine. Notice also that it's bookended by the same angle and its opposite side. Same angle, opposite side, same angle, opposite side. So that's another good way to memorize this. And I'll kind of talk you through it as we work these, again, kind of reinforcing how I've memorized this particular formula. So let's try a few. Here are two, if I can get this centered, there we go, two examples that we can use. Notice that for this top one, I've got sort of a side angle side situation going on. So I've got 60 across from A, so I have a known angle and an unknown side. Well, if I were to use 10, this side length, well, then I would need to know angle B. Well, notice I have no clue. All right, well, let's try the other one. I've got 8, so I need angle C. Well, notice I'm kind of out of luck there. So in these side angle side situations, we're really sort of stuck. We're going to have to use our law of cosine rather than the law of sine. Obviously, if I knew what angle C was, making this up, maybe it's worth 40 degrees, well, then we would have plenty of information. In this case, not near enough, so law of cosine is what we're going to work with. I notice that I'm trying to find side A, and I know angle A. And remember, they're bookended with the formula. So again, here's how I memorize the formula. I've got A squared, and I've got B squared, and I've got C squared, just like Pythagorean theorem. Notice the only difference is we've swapped the equal sign and the addition. We've swapped those. All right. We've got subtraction next. Notice I have B and C here. I need two of them ultimately. So there's one set. Here's my second set. So that's how I remember that. And then, of course, this is law of cosine. So cosine has to make an appearance, and we bookend with the A. So in this case, I need angle A and then side A on the other side. So again, just my way of memorizing it. Let's plug what we know in, and then we can start our work. All right, well, obviously I'm finding A, side A there, so I don't know it. So we'll go ahead and write that in. A squared equals B, we know is 10, so 10 squared. We know what C is, in this case 8, so 8 squared. We need 2 times 10 times 8, so again 2 times B times C. And then cosine of angle A. Well, in this case, angle A is 60 degrees. There we are. Now, here's what I tell people not to do. Do not try to type this entire string into your calculator. Inevitably, you will make a mistake and do something just silly. Here's what I recommend that you do instead. Do it in pieces and do it as much paper, pencil, or really small bits of calculator as possible. For example, I know that 10 squared is 100. I know that 8 squared is 64, and we're going to go ahead and add those. Order of operations allows me to do that. So 100 plus 64 is 164. All right, so we've simplified that portion. Let's keep going. I know that 2 times 10 is 20. 20 times 8 is 160, so subtract 160 multiplied by the cosine of 60. So notice I took something that was pretty long and drawn out and now I have simplified it down to something that's going to be a lot easier for me to type in. I don't have to remember all those powers of 2. I don't have all these operators. Much easier to type in. So this is where your calculator comes into play. Again, I would strongly urge that you double check every time, hit mode, make sure you're in the correct mode for your class. For my class, we're measuring in degrees, though obviously as you get in higher level maths, you might need radians, then you'd need to select it. But we've got degrees here, so we're good. Let's type it in. So 164 subtract 160 cosine of 60. Make sure you close those parentheses, get in the habit of doing it. Trust me, it'll bite you in the butt later if you don't. And notice we get a nice whole number, which in trig is kind of odd, but it happens every now and then. Even a blind squirrel finds a nut. So a squared is equal to 84. Now remember, we don't care about what a squared is. We just need a. So there are a couple variants. One version is, of course, take our square root here on both sides, and we would need to simplify that square root if we want an exact answer. I know that 84 can be divided by 4. Square root of 4 is, of course, 2. And then 4 times, as it happens, 21 is the other factor there. So that is the simplified version. Notice 21 is not a perfect square number, neither are any of its factors. So cool, that's the exact answer if that's what we were asked for. If we were asked to find a, in this case, that side length, and to round, maybe we asked to round to the tenths position, then we could approximate it and say, cool, what is, say, the square root of 84? So if we're rounding to the tenths place, roughly 9.2. Make sure that 9 is easy to read. Also, notice I could take my 2 radical 21, and we get to the exact same answer. So simplified version is the same as that square root 84. And then, of course, we have our approximate of 9.2. Whatever units, feet, miles, we don't care. So one time to use this is if we have a side, angle, side scenario. If you see that, then law of cosine is probably what you're going to have to reach for, unless, of course, there's other information that you know. Here's another situation where law of cosine comes in handy, and we see this a lot, is that we have all 3 sides and no angles to go with. Notice if we had even just one of these angles, then we could reach for that law of sine and life would be so much easier. Unfortunately, life's not always easy. So we've got our 3 sides here. Notice we're asked to find angle R. So the equation that I'm going to write is from angle R's point of view. So I'm going to start off of cosine angle R. And remember, up here, there's our cosine of A. So on the other side here, I want the side that matches it. So I'm going to want side R, so that's 23. Because notice we've got angle A and side A bookending, so I need angle R and side R bookending. So now I just need my other 2 sides, so 18 and 37. So 18 squared added to 37 squared. Subtract. Remember, I need those to appear twice, so 2 times 18 times 37. Now, at this point, again, you're going to be tempted to try to type all of that into your calculator. Oh, forgot my square here. You're going to be tempted to try and type all of that into your calculator. For the love of all that's good, don't do that. One piece at a time, folks, one piece. So let's go ahead and do our 23 squared. That should be 529. All right, let's do this next part together. So we can take 18 squared, add it to 37 squared. Again, the, I can't think. Order of operations, good Lord, you think a math teacher can remember that? The order of operations allows us to do that without any repercussions. So that would give us 1,693, subtract. Let's go ahead and multiply that out. So 2 times 18 times, what is that, 37. That gives us 1,332, yeah. And then, of course, cosine of R. Now, that we're at this point, we typed in just, again, sections, 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 much easier. We need to go ahead and subtract both sides by 1693. So 529 subtract 1693, and we get a negative 1,164. And then on the other side, a negative 1332 cosine of R. Do not forget that negative sign. Careful. All right, so now that we're here, we need to divide both sides. So let's do that. Divide by negative 1332. Oh, good Lord, isn't that a terrible number? So what I'm going to do is I'm going to write just an approximate version here, just to save myself the, here's the math so you can see it. I'm not going to write all of that down. That's ridiculous, but my calculator has stored it. So here's what I'm going to do next. So that equals cosine of r, I need to use my inverse cosine. So what I'm going to do on my calculator, get that out of the glare, what I'm going to do in the calculator is second, inverse cosine, second, and then the key you'll push is this negative key. That'll take our previous answer and plug it in. Cool. And if we're rounding to the nearest whole degree, we can say that the measure of angle R is approximately, we'll call that 29 degrees. And there it is. And then from there, we could use it and say use our law of cosine if we wanted to figure out other things. But for now, that's all they want. So cool. That's where we'll stay. So let's talk about how this works. Why does the law of cosine in all of this nonsense, why in the world does it work? Now let's talk about a proof. So here's our proof for the law of cosine. Again, set up very similar to what we did with our law of sine scenario. We just got a nondescript ABC triangle with a not a hypotenuse, with a height and altitude here. That's point D there. There it is. Set up basically the same way. The only difference is we're going to take this side A and we're going to cut it up. We're going to have x on one side and A subtract x on the other. And you'll see why in a second. So take a look. Here's the version of the equation that will prove. Obviously, we could prove any of them just by moving the height around if we need be, but we're here. So our first step, and by the way, the one thing I don't like about this particular proof, the way it's set up, is it never addresses the given within the proof. I think that's sort of sloppy, but neither here nor there. First thing we're going to write down is we've got c squared, so this side, is equal to a subtract x squared added to h squared. That's just Pythagorean theorem. So cool, there's one right triangle. Let's skip down. We're going to skip step B for just a moment. Bear with me. Take a look at step C. X squared plus h squared is b squared. Well, that's another right triangle. So that's another Pythagorean theorem issue. Now, what we're going to do is we're going to use these two right triangles and what we have here, so that's why the ultimate formula has that sort of Pythagorean theorem-esque look about it, is we're going to use those two combined to get what we need. All right, so here we go. Step B. Notice all they did was take a subtract x squared and actually work that out. So they just expanded that. So this is simply, we could call it a substitution step. We took this out and put this in its place, and all we did was basically take everything to that power of 2. So we'll call it a substitution step. All right. So our first Pythagorean theorem, we've kind of altered it, all right, kind of expanded it out there. We've got our Pythagorean theorem again for our second triangle, the one here on the right. Take a look at D. Notice that we have in part B as in boy, we've got this x squared added to h. Well, notice in this second triangle, we have x squared added to h, and it's equal to b squared. So we're going to take the x squared added to h out and put b squared in its place. So from B to D, the only difference is we took x squared plus h out and put b squared in its place because in step C, we saw that they were equal. So that's substitution. Excellent. So from here, we're going to take kind of a side step. Notice the cosine of angle C, so C is here, adjacent over hypotenuse, so x over b. So that's just by the definition of what it means to have cosine. So this is definition of cosine. Right? That's what it is. It's opposite, or excuse me, adjacent rather over hypotenuse. So by definition, cool. We're going to rewrite it. So another substitution / multiplication step. Obviously, we multiplied by b on both sides to get there, but we'll call it substitution. Excellent. Now notice, we know what x is. X is equal to this. Okay. Notice in part D, we have an x. So what we're going to do is take that x out and put b cosine c in its place. All right. So we took the x out and put b cosine of c into its place. So that's a substitution step. And then this last step, notice it's simply rearranging G in H's line here. So we can call it a commutative step. That's simply the commutative property, meaning we can put things in any order. So notice the reason why that first part looks like the Pythagorean theorem is because it's based on partially the Pythagorean theorem. And then we interject that cosine bit in because we can figure out that distance x and relate it to how it compares to that cosine of c. So there in a nutshell is how that works. All right, let's look at a couple more examples and then we'll call it a day. All right. One thing that I must encourage you to do when we're working with non-right triangles. First thing, see if there's any hints that you could have a right triangle. So maybe you've got enough information. Let's pretend here. Let's pretend that 8 and 10, maybe you've got enough information to know, oh, this is a right triangle. If you can figure out what you're dealing with is a right triangle that just hasn't been marked, then use what you know about right triangles, Pythagorean theorem, maybe special right triangles, maybe trig, all right? Just your basic trig functions. Use those to your advantage. They're quicker, easier, much less likely for you to make a mistake. If you look at a non-right triangle, or what you believe to be a non-right triangle, and you realize, oh, law of sine comes into play, then by all means reach for law of sine first. If, however, you look at your situation and realize, nope, there's no way around it, I've got to do law of cosine, well, then reach for it. But it should be your last resort. So notice, for problem 19, it appears at first that I don't have enough information. However, notice what I could do. I'm asked to find g in this case. Well, actually, I'm asked to solve the triangle, but g is given to me as a variable there. It would appear that maybe I don't have enough information to do what I need to do. But notice I've got angle across from a side, side across from an unknown angle. Well, that's enough information. I could figure out h pretty quickly. Take a look. I could use the law of sine, sine of 40 over 10, equivalent to the sine of h over 8. And I could use that to find whatever angle h is. All right, so let's do that real quick. So if I do it, I'll end up with, let's see, we'll multiply by 8 real quick. So that's 8 sine of 40 over 10 equals sine of h. And then what we can do real quick is take that and use an inverse sine. So the inverse sine of 8 sine 40 over 10 is equal to h, in this case, angle h. All right, well, I can find that out pretty quick. Let's do it. Again, I'm going to type it in a piece at a time. I'm not going to try and type all of that in. So 8 sine 40, parentheses, divided by 10. Cool. Second, inverse sine of our answer. Cool. So h is approximately 30.9. So that's what I'm going to say for h, roughly 30.9 degrees. Now, here's what I'm not going to do. I'm not going to use that approximate version throughout. All right, so notice here's what I'm going to do. I'm going to take that. I'm immediately going to add 40 and then subtract 180. And while, yeah, it is a negative version, that automatically gives me g. So g in this case is 109 point. Well, if we're just rounding to the tens place, it is what it is. So we'll call it 109. Well, I guess we really need to make it 0.1, don't we? If we're rounding to the tens, suppose we do. There we go, degrees. Now I've got enough information to solve for g, but I want to hold on to that. So I'm going to multiply it by a -1 just so I can keep that number in there. Watch what we're going to do. Make a line. So I've got that number, so sine of g, so this 109.1 over g, all right, we don't know it, is equal to, I'm going to use the 40 and the 10 because those are not rounded numbers. So sine of 40 over 10. Let's rewrite. So I'm going to multiply by g, multiply by 10. Here we go. So 10 sine 109.1 is equal to g sine of 40. And then we'll divide both sides by sine 40. So 10 sine of 109.1 over sine of 40 equals g. Now, let's go back. Remember, we said this is ultimately what that 109.1 is. So I'm going to do 10 sine of my answer, so that 109, close parentheses, divided by sine 40. What this is going to do, folks, is it's going to give me a nice exact answer, or at least as close to exact as we can be. So that tells me that g is roughly 14.7. So 14.7. And that's going to give me And that's going to give me as close of an answer as I can get and still be accurate. So we've got G for 109.1, G for 14.7, and then H for 30.9. Now notice we did have a side angle situation, so we might want to look for an ambiguous case just to see if it would indeed exist in this case. If it does, then cool, we would need to work for it. If not, then we're good. But again, I'm not going to do that here just because of time, and I want to show you how to do one more law of cosine issue. So let's take a look. Notice in this case, I'm not going to be able to use my law of sines. I've only got side lengths, so law of cosines is what we're going to have. So I'm going to solve for B first, just because it's here. So what I would do is put angle B, so we got cosine of B, capital B, and then 18 on the other side here to bookend it. So now I need my other two sides. So 11 squared, 15 squared, subtract 2 times 11 times 15. And again, I'm going to type all of this into my calculator a piece at a time. So for example, 18 squared is 324. 11 squared added to 15 squared gets me 346. Subtract 2 times 11 times, what do we say, 15. That gives me 330 cosine of B. All right, so let's take that 324. We'll go ahead and subtract the 346. So that gives me a negative 22 is equal to a negative 330 cosine of B. Again, remember that is negative. Don't drop it. So we'll divide by a negative 330, and we get a terrible, terrible number here. We get approximately, 0.06 repeating. Isn't that fun? Cosine of B. We'll use our inverse cosine, so second inverse cosine of our answer, and we get an answer of approximately, so the measure of angle B is approximately, if we're rounding to the nearest, what are we asked to measure to? Oh, they did tell us to round to the nearest degree. Well, it's okay. Nearest degree in this case would be 86. But again, I would not use that number in my work. Now, we could use law of sine from here on out to do our work. However, the concern there is that every time you do it, you're going to be relying on some form of a rounded number. So what I recommend you do is just continue on in the same pattern. So for example, we would solve maybe for D next. So I could say cosine of D, and then on the other side have 11 squared, and then our other two numbers. So 15 squared added 18 squared, subtract 2 times 15 times 18, and then work that out, figure out D, and then come around yet again and do the same story for C. I'm not going to do that here simply because I think you get it. Again, if you have any questions or concerns, please let me know. We'll cover this in class in more detail if you're not sure about how to do it, or if you're having issues with your calculator, just making sure that you can type things in accurately. Again, bring your questions or concerns with you. Otherwise, have a good day, folks.